None of you are here to see me, but I do have to tell you where you are. Welcome to South Park Commons, New York. Put your hand up in the audience if you are part of South Park Commons. After the event, if you want to learn more, you should talk to them. Quick note on SPC, I run our New York office with an amazing team, Suzanne and Arian. We've been around in the Bay for 10 years, but in New York for a couple now. We're basically a space for deep technical exploration. So we try to bring together the smartest people who want to solve the hardest problems. We want to bring them into our space. We don't take any equity. We don't charge. We just want really smart people to come together, and hopefully we get to invest in a bunch of you and accelerate building businesses that might one day look like these guys. So if you want to learn more about SPC, if you're curious about what starting something or doing full-time technical exploration could look like, I'm always around. And with that said, thank you so much, all of you, for coming, and I'll hand it over to Eric to kick it off.
Hey, I'm Eric Newcomer. I'm the author of the newsletter Newcomer and host the Cerebral Valley AI Summit. Thrilled, man, this is quite the crowd and people are eager. So I will not talk too long. At some point I'll open it up. We definitely want people to engage. I think these are three companies truly at the cutting edge. So excited to get right into it. Do you just want to introduce yourselves and sort of give the brief what your company does?
Yeah, sure. Hey, everyone. Good to be here. I'm Joseph Kraus. I'm one of the co-founders and the CEO of Radical AI. And what we do is build AGI for science. So we are discovering new materials with an AI scientist in a fully robotic lab that can actually impact some of the most important industries in the world. So that's us.
PIM, General Intuition. We build general agents for environments that require deep spatial temporal reasoning. So think things like robots or moving around in simulation.
I'm Rob Cochran. I'm a co-founder and CEO of Fauna Robotics. We're building safe, reliable, and fun robots for everyone. Our first product, Sprout, is a 3.5-foot tall humanoid robot that we've made available as a development platform.
All right, we get right into it. Rob, Amazon has bought your company. Why did you sell it? Tell us the story.
Yeah, so this news came out last week, obviously much longer in the works. I worked at Amazon previously, several years ago in AWS, and had a bunch of relationships there since starting the company. In many conversations, discussed partnership and different things we could do together. I think ultimately they really liked our vision for how robots would one day work and live alongside people, and wanted to support that in a big way. And the chance to get to keep doing this and doing it in New York and with a lot of support from a great partner, felt very exciting.
And so you're going to lean in on the form factor you're doing, which is sort of acute research robot. Like, give us the articulation of why you're not going straight to humanoid robotics.
So, though we have started with a 2-arm, 2-leg robot named Sprout,
cuteness is part of the...
Cuteness, approachability, something engaging, something people actually want to be around. I think the reality of robotics today is that they don't work perfectly. And so, one, it has to be safe. So if you have a 150 or 200-pound machine that falls over you or falls into a child, that's it. So you obviously can't deploy that kind of risk into real environments. And I think there are still many innovations required to make robots work very effectively in homes. And so having a platform that is experimentally deployable in a lot of situations is very useful. And then making it something that people want to be around so they're a little forgiving of some of its faults.
All right, Pim, first of all, you come out of like the video game world, right? You were running the largest RuneScape server at 14? That's a correct fact. I think I do all my prep with Claude now, which is dangerous, but it's so good. That's accurate. All right. And then basically you had a company that had access to tons of video game clips. You go out, you start pitching them to foundation models, and you figure out, actually, data is pretty valuable. Like, maybe I should build my own company off of it. Is that a fair origin story? Or what is the sort of, what was the idea behind General Intuition?
Yeah, so I was too young when the mobile sort of revolution happened. And I think
Hold the mic up slightly.
I come from consumer, so I looked a lot at like, well, do platform shift, like usually the biggest companies are built right after these things called platform shifts happen, which is when there is like a large like unsettling of the status quo and like how things are built or how networks come together. And in video games, Discord was a large platform shift, and so Metal came on top of Discord largely. Metal is one of the largest video game recording applications. And so I was too young for mobile. What I saw when the LLMs happened, I was already fairly obsessed with like reading the papers and trying to understand how this works. And then decided to go all in. And then indeed we just started looking at how the data could be useful. Like originally we had some ideas of like, oh, can you take Factorio clips and use them to create the best players? And can you evaluate like language models on how they would do certain things? And then we actually realized that the data set was so general that games are actually a very good representation of like digital information, i.e. text, which like robotics lacks, right, in the physical world. And then in the physical world, you have spatial and temporal dynamics where like things unfold over longer periods of time, which text then lacks and pictures lack. And so we sort of realized that we had so much of this data that we could pre-train entire foundation models on it. And we've been able to do that very well.
You're building agents for real world, real world. But the world models are built from video games. Is that right? Like, what is your view on whether like the successful world models, because that's such a buzzy term right now, will be based on like mapping this room, or based on video games just because there's so much volume? Obviously, we saw similar debates with self-driving cars.
The phrase is so broad now, it's very difficult to give like a succinct answer, but I'll try. So what started world models is actions and frames, right? So you have an action, and then you have an observation, i.e. the next frame, and then the next frame can be generated off the action. That's kind of the original term, I guess. Or the next state. I'm using the word frame in this case because it's more familiar, but the next state of the environment is like generated off the action that you take. That sequencing of data just doesn't exist in the real world in a, and what's important is a timely, accurate way. So if you want your models to properly react to the actions you take, then you want to be able to separate out the action from the state, right? So the action from the world. As humans, we don't have that. And if you want to label it off video, even the best humans, right? They will not get that precise within like, 100 millisecond range. If you want your models on very little data to learn these causal relationships, then you actually want that to be ground truth. Therefore, actually getting it from video games in a software recorder.
Because there's a faster...
You actually control how the frames and the actions are being put together, and therefore we just found that you could pre-train on that and then do a lot more afterwards. So we found this to be, in our opinion, like a great way of doing it. Now there's other companies that will try other ways. We'll see how it plays out.
All right, Joseph, Radical AI, in some ways it is what people think with the frontier, like find new materials. And you have, Raytheon is like a big backer, so this is like outside, the serious companies thinking about this. Like, what's your approach, I guess, to finding materials? And then like, what is materials even the word you use? And like, what is then the first material you're hoping to stumble upon?
Yeah, I think it's kind of worth maybe taking one step back, right? And I think the thing I always like to talk about, and you might have heard me say this before, is what do materials mean? Why are they important? Why are we working on this technology? And the reason is, if you really paint the picture, right, and you think about how many industries are impacted by material science, automotive, aerospace, manufacturing and defense, climate, energy, semiconductors, electronics, most important industries in the world, all a direct result from materials R&D. But when we were paying attention, and we can get into like why we started the company, it just takes way too long, way too much money, and way too much fragmentation to solve them. And so the big thesis behind the company is this connection between an AI scientist who has a ridiculous level of intelligence. I mean, better than a PhD scientist would have today, and we're a couple months into training it on kind of real experimental data, and then a fully robotic, self-driving lab. And that means that we can actually run experiments, kind of synthesize materials, characterize materials, and then test materials in high throughput. And we capture all of that information. None of that information is captured today. And so you build this data set that does not exist in the experimental lens, has really important information. It's the actual real world impact of materials and the way they perform, and then can actually be used to kind of push those materials to end applications. So Raytheon's an investor, NVIDIA is an investor, Eni is an investor on the energy side. We do a lot of work in nuclear fusion. And so you kind of have all these companies.
Materials is huge, all the world.
Yeah.
Like, where do you start? You know, it's
Correct.
like anything could be useful.
That's right. And so where we thought about was like, where's an area that really has so much opportunity to show why the technology is relevant? And in the space that we work, which is called structural metals, there are 10 to the 40 different potential combinations. So I want you to envision this, like, that's like 100 trillion Earths of different potential combinations that you can go synthesize. That'll take like 7 million years if any of you try to do that. That's where AI is really good at weeding and self-driving labs are really good at making. And so that's why we kind of chose that area. Aerospace, defense, and energy are the areas that we're working in today, and then kind of moving into semiconductors as a future area, which we can talk about.
Is there like a very specific sort of?
There is. It's called a high entropy alloy. So it's a material that has 5 to 7 different elements in it, and they're all about equally atomic, and it has really high entropy in the system. And so what it can do is have incredible properties at crazy conditions. You're like flying through space at Mach 10. It gets ridiculously hot, ridiculous pressure, and it's really oxidative. It's really corrosive. These materials withstand all of that, so they don't feel the effects of those conditions. So they're pretty exotic in that way.
How much, this is sort of for everybody. I want to understand, like, how much was ChatGPT and what's happened with like the language models, like an inflection point for what you're trying to do? I know some people came after that and everything, but like, was that a core technology to what you're doing, or do you see the actual like technological leap as being something totally different?
Yeah, I mean, for robotics, it's definitely a huge innovation and step forward for planning. So if you think about, hey, robot, grab me a snack from the fridge, the ability to plan that task out flexibly and accommodate, you know, oh, it gets to the fridge and the drink that your favorite drink's not there, so can it pick another one? That sort of planning and replanning was just not possible through, you know, formerly possible structured planning routines. But for us, I mean, there have been many innovations. The availability of embedded GPUs that can run on device in real time, actuators that you can buy off the shelf to, you know, animate the robot's body. And then for us, and my partner spent time at DeepMind doing work in simulation, and the availability of physically realistic simulated environments where you could train robot behaviors and have those behaviors actually reflected on a real robot was not possible, and not a way that people developed robot behaviors, you know, 5 or 10 years ago, and is now quite possible, and with accelerated compute can be done at scale. And that's, I think, driven a real set of innovations more from a robotic control perspective, and is AI, but it's not language models.
Yeah, you know, obviously it's sort of the next generation of language models. How would you draw sort of the connection between what you're doing and the work that's happening in language models today?
I think that the last point that he made was quite interesting on the simulation piece. I want to just explain that a little bit better because I think it will make everybody understand why it's important. So previously, you would have to hire an engineer who goes and codes up in a simulated environment, and then you do it in an engine. That engine is like probably roughly, you know, modeling Newtonian physics or something, and you don't know precisely how much because it made some trade-offs in some places, right, to go faster. So then you need to check how far off they are. And then now what you can just do is you can just create verifiers where you just look at like the outputs of the engine, and you can just have an LLM go crazy, put together a bunch of environments, for example, and just pick ones that work well. And so I think the role of the engineer in a lot of parts of the stack has moved from the person actually controlling the number of output to just verifying the output and then using that as a way of, so it's a massive force multiplier. The size of the teams that you need to do what you needed to do before is massively less. I think LLMs are in many ways just a way of, like the simplest way that I describe it is all the time that collectively as humans we spent like searching the internet, reading things like Stack Overflow, and then typing it. All that's just compressed, right, into like a very easy sequence. And so now, I think it's many exponentials of speed ups, and like it's funny the work that we all do, which has in common, which is that we saw what happened in text, I think, and so you see. And also, like looking at the scaling laws and all the techniques being developed for like pre-scaling, or pre-training, all these things are all extremely important, right? They're all quite general. a lot of the models, a lot of model architectures, a lot of the pieces you also can directly transfer. And so, yeah, all super fundamental work. I actually think people don't realize how similar it all is under the hood.
Yeah.
I agree with that last point entirely. I think there's so much similarity that comes over, and even things like you learn about training, right? Like, did ChatGPT learn the English language? Well, no, of course not. It learned how to represent that and then use that when it produces text. And I think we think about similar things in material science that we learn from the language field. We also use it, and I think that's important. We have this like head honcho who runs our science. He's like the guy in charge. He's like the new PI of the lab. And that's an LLM. Like it's from OpenAI and Claude. We fine tune that to understand materials, but he doesn't. That agent.
Do you give him a name internally?
He's rad. So it is. That agent just calls the tools that he needs, and it's really good at understanding. Like, okay, I want to go into simulation. I'm going to run quantum chemistry. I want to run labs. I'm going to talk to my APIs in my lab.
Is he like the type of PI where it's like, I don't need to explain this to you. Just trust me. I'm an expert in this.
It depends.
Like, do
It
it. Or
depends.
like, how much do your humans come around and like figure out why it says go this way?
So we do that a lot today, and it's really important to label the data for like a common industry phrase, meaning how does it know if an experiment is good or bad? Well, a human scientist tells the agent that. So we'll come in, the agent will analyze the result from the lab. Our human scientist will analyze the result from the lab, then we'll compare them. And you build this training data set of, okay, I understand what the human scientist is going for. So the humans are definitely in the loop today, and it's really important. But there's a bunch of other kind of technologies that we custom build. Diffusion models are a perfect example. There's not a real good diffusion model in materials today. We have to build that from scratch. We would never build an LLMs from scratch. So I think they're important in the learnings, and they're important in how we can use them in our workflows today.
In 5 years, like, what's the world look like? That's the fundamental question. Like, robotics. Like, I mean, there's the sort of like, will humanoids happen that quickly or not? Like, what both on the sort of bullish end where you're bearish. Like, how is the world sort of more different than we expect in 5 years? Where do you think? Oh, I don't know if we're going to make a leap. Like, in your domains or any area that would be interesting to people building here.
Yeah, I mean, from a robotics perspective, I think there's definitely still a lot of work to be done to make robots very effective across the broad set of tasks that we'd like to eventually have them do in the home. That's part of why we started with the development platform. So AI labs in academia and corporate research labs are able to kind of build and extend and develop some of these capabilities. I think some of what we're hearing here is that there's a lot that still needs to be done to ground robotic simulation in physical reality, and to be able to make forward projections that are realistic and understand physics of the world.
So you don't believe like, oh, we're going to have AI is going to hit some sort of self-improvement point, and so that the rate of development is going to change so much over the next 5 years that we just
I think we are on a very
ahead.
steep path where we're figuring out a lot very quickly, and we should see robots very broadly, in the world, and we're building and shipping robots today. But I think we are on a very steep path where innovations still need to happen with people.
What one specific thing that maybe in 5 years you'd hope to see? Or Pim, you can be our futurist.
I'm going to steal this. So I'm stealing this from Andre Kaparthi. He said it in a talk privately once, and I really liked what he said. There's broadly 3 stages: bits to bits, so anything digital to anything digital, where there's lots of information available. Bits to atoms and atoms to bits as like an interface layer, and then atoms to atoms. Those are like the 3 stages of like quote unquote AGI, and they all have very, very different problems. Bits to bits is in hyperdrive, like we're flying. There's no limits in sight. Bits to atoms and atoms to bits is largely constrained by measurement systems that we still need to build, and I think it's a very interesting space, right? Like a lot of the work you're doing, I'm sure is you could see as starting as bits to atoms to bits and ending up in atoms to atoms, right? And then eventually atoms to atoms, where you have completely end-to-end physical systems modifying other physical systems, and really I just look at it as a number of combinations of things that are possible in the world, and the pace at which we produce them just goes up so fast that you just start seeing a lot more things a lot quicker. And I think so the same thing you're seeing with like web apps being developed on the internet, like all your friends can develop apps now. You start seeing that with lots of different things, And I think that's really just, I think that's how it plays out.
What this is sort of a zag, but I just want to understand, like, who are your first customers, or like, what do your customers look like?
So at the moment, our customers are any robot that can be controlled using a game controller. So what we do, right, is we build world models and also policies or agents that then are trained inside and evaluated inside the world models. And what world models are great at is sort of simulating stochastic environments that would be very hard to simulate in like traditional physics engines, or like you'd have to do a lot of like manual coding, right? And so you evaluate a robot not by how it does when you walk down a straight or when it drives down a straight route, but you evaluate it by how it does when something unexpected happens, right? And so that's why you need lots of stochasticity and unexpected things to happen. That's why world models are great. So our customers are typically robotics customers that you can control using game controllers, because a lot of the data obviously is gaming actions, right? And that's the general solve, which is really cool. So you don't need to solve for like precise motor torque predictions. You can just solve at the input of the game controller, which every robotics company already ships with. And then I think on the humanoid comment, I think I'm less optimistic on humanoids, not home robots and like actual. So I view AI as largely also an interface problem. Which is funny as like a person who builds models. Like I think it's largely an interface problem. Like we didn't start paying attention until ChatGPT, which was largely just an interface, right? And so same thing with like home robots. Like it's you know, if I go off first principles, and I think humanoids are interesting, but largely the reason why humanoids were picked as an embodiment were because the assumption was around that that's the only place where we had large scale data because of humans recording themselves, so from like the egocentric point of view. And also, I think at the end of the day, you don't want like heavy, bulky, many thousands of dollar things that require energy if you don't need them. In many cases, if you can control the devices themselves, it's probably a better solve. And so I think in the home, they'll be big because I think there's lots of like very random tasks. I think in factories they'll be big, but like I don't think it's like the everywhere thing that we're imagining. I think because I think they're just hard to manufacture. I think you'll start seeing specialized systems that people buy much sooner than you see like very general humanoid robots as like the general thing everywhere.
For radical AI, to go back to this like bits to bits, bits to atoms like framework, which piece is the hardest for you right now, and like where are you in that process? Is it still sort of like bits to bits idea generation, or?
Yeah, I like the framing. We call it, in our industry, it's kind of called concurrent engineering. And so like a lot of the systems that we build today, whether that's a fighter jet all the way through to like maybe a humanoid, those technologies do not design, particularly the materials, but other systems in concert with them. So like in aerospace, when we design a new turbine or we design a new plane, we go back 30, 40, 50, 60, sometimes 100 years to pull the material to use. And that's true in the automotive industry today. A lot of the cars we're driving, 1907, 1910, like Ford Model T alloys. It's crazy to think about. Like, how are we at AGI and we're using 1910 alloys? So kind of this like, atoms, bits to atoms or bits to bits, like we view this world where if you're designing a new plane or a new car, like you should be designing the material at the same time that directly meets the requirements and constraints that your product is going to have. We're close to that. We can't do that at scale yet, but our scientists can talk to our AI agent. I want a material that does this. That agent will go run a bunch of calculations, figure out what an example that is, send it to the lab, and then make it. So you're really going from voice to end material. And it's not perfect yet. We're still building that technology, but man, if you get that at a loop where anyone can do that on our platform, like again, now every automotive, every aerospace, every mechanical engineer in the world has materials customization available to them.
And how do you monetize that?
So for us, our end goal is to actually sell materials. So what we do is we're capturing the largest experimental data set in the world because we're running experiments. And when you have that data set, we have a deep belief that that is the fundamental underlying technology you need to make these models relevant. When you can put this whole we call it the flywheel together, you can start to target things like RTAP superconductors, for example, or high entropy ceramics, or new battery cathode materials. We want to sell those materials to the industries of the future. We always like to say, we don't focus on optimization-based technologies. There's a bunch of companies that optimize existing products. We focus on enabling-based technologies that are not here today and will be here tomorrow because of Radical AI.
You will then own the patent and.
Yep. So
and
we'll like make them. We'll discover the material, test it, and then actually manufacture and scale it.
Let's we have a lot of people here who maybe some of them want to know what company they should start or what space they should go into. Do you want to sort of like the company you wish you could be doing besides this, or just areas where you think there's opportunity? Obviously, Rob, I mean, you were in sort of the control labs, like the human sort of machine interface. Is that an area you're bullish on, or just spaces you think people should be running at right now?
Yeah, so our previous company, Control Labs, which we sold to Meta, was a wearable neurotech device. So you wear it around your wrist, picked up a signal known as electromyography, interfaced to a computer, and let you have very high bandwidth control over a computer interface, whether that be VR, AR glasses. It is now part of the AR glasses that Meta ships. And I think in general, there are kind of two trajectories, one towards highly immersive technologies and then maybe more towards embodied technologies. And I've worked on either side of that, but I think both of those, it's core to think about the user and the person. And I think a lot of times what gets lost in robotics and with kind of immersive technologies is...
Sorry, I actually don't know which is which. Which one is sort of in the brain?
So what I would say is, with AR, we are projecting ourselves into a digital space, and with robotics, we are pulling out, and robotics are embodying the AI itself. So it's kind of two sides of the same coin. But in both senses, you're developing technology to interface with people, and there are interface problems all over the place in terms of making things that people actually want to interact with. They can be optimistic about the future of the role we play alongside AI in various forms, and I think there's a lot of innovation to be had there.
So just this core, like, how is the human interacting with all this like capacity?
Yeah, and I think you see a lot in the devices space right now. What a personal AI is going to look and feel like. Is it going to be a phone, or is it going to be glasses, or AirPods, or whatever it is? And I think there's a lot of things to happen there.
Do you have one you're cheering for?
Not yet.
Pim, space you think people should be running at?
Yeah, okay, so a few things. One, I very strongly disagree with the claim that we are at AGI. I think it's like I think we have like better than random idea generators that get increasingly better than random at an increasingly rapid rate. And we just so happen to have so much data on the internet that we can construct them to now do useful things, so long as those things are represented largely in text space, right? And that is such a like black hole of where everything is being sucked in that companies are increasingly exposing everything in text space, like tool calls and things like that, because otherwise you miss out on being part of that interface, right? So I think that like my definition of AGI is like far from being met. With that said, so it's incredibly like even being in the space, I just find it incredibly difficult to predict what somebody should do. I think that people should be spending a lot of time. We're spending a lot of time thinking about like how do you enable jobs or education in like this new world. I think it's like I love like half my childhood.
You're like, it's not AGI, but everyone might lose their job.
No, yeah, well, yeah, but how many jobs are people spend on
right,
their
well, your
computers?
standard's very
Yeah.
high. Aren't humans somewhat random and inconsistent in our reasoning?
Yeah, I think we can match it with like execution and like checking whether it's like a correct. I don't know. I think there's a lot of things that humans are still very special for. But I also see the pace of the change of the technology, and I can't say that like I think that that's going to be like a forever thing, right? Yeah, I don't know. I spent a lot of time thinking about like how like there's just really interesting. There's two things consecutively broken. One, hiring is broken because everything is LLM generated and bullshit, and then second, nobody's getting hired. So like this is one thing that I run into every single day. Is like, okay, it's just because we're not surfacing the right people the right ways. I think science is, so I look at, and maybe this is my framework of thinking through this, there's a lot of fields that were enabled by text. Science is one of them. They sort of came after the innovation of text itself, which is largely, in my head, like a way that we compress real world information, right? So like we see a bunch of things, we would describe it. It was a room full of people, a bunch of people wear different color shirts, right? Eric Newcomer was there. We compress all that information into something that is relatable and quick to communicate. A lot of fields came on top of text. We, as humans, invented text, right? Math, physics, a lot of these things. And that's where you see sort of the completely rapid innovate, like really without limits, because you can build verifiers in text domain, you can do the whole thing. So I think building things on top of the rapidly accelerating field that can be described mostly in text, or most of the communication of that field is in text, something around there is probably the right way to bet on the LLM curve or foundation model curve. And then to your point, I think we're going to see rapid innovation. If you really like physical systems, like now's your time. Like go figure out how to manufacture these things and be really good at it, because you're going to get a ton of optimizations in the next year or two.
You're welcome to respond to AGI if you want, but we don't need to get lost in that. Otherwise, yeah, just an area you think people should be running at. You come at this, you came up through the Army, right? As part of, so you've sort of seen some of these problems from a totally different lens. Are there other areas you think people should be building companies?
To me right now, and I work in hardware, but there are 3 areas I just think they're most value in the world will accrue, and I think there are subsets of each area that you can go very deep within. There's like AI and data. I think interfaces is like a perfect example. That is a sub area of that. If someone can build holographic technology, like for my agent, like I'll pay you today for that product. But I think we're seeing like interfaces be important. I use an agent every day. It like is a part of my workflow. The entire company is required to use agentic frameworks. Like that's the world we're going to. And so I think interface is a cool example. I'd love to see it. Compute and energy to me are in industries that have been historically very hard to disrupt. Compute has had a better wave of disruption. Like there's been in-memory compute, neuromorphic compute, like different alternatives trying to get kind of ASIC-based accelerators for AI. I think we've seen a wave there, but we're still on a Moore's law trajectory of compute. So like what comes after 2 nanometer? Well, it's 3D heterogeneous structures. There's a lot of unknown problems like when it comes to that. From like the compiler down to the transistor. There's a lot of interesting work to do there. Energy had a wave, crashed in a wave because it was early and the technology probably just wasn't fully there yet. But now we're coming back to this place where we're energy constrained. And so what does the future of solar look like? Energy storage, nuclear is certainly interesting. Of course, we spend time there. I just think like those areas, and I'm sure there are like a million things you can think about inside them, they're going to power the future of the world.
Great. I'm going to open it up soon, so start thinking. Rob, just, it's easy to get lost in like the science of it all, but I mean, you've sold 2 businesses. I feel like often with like frontier technology, it's like build the biggest business ever, like change the world. Like what advice would you give to founders about sort of, thinking about an exit and like big companies and how much do you court them? And just give us some tactical advice from your experience doing this.
Yeah, well, so I think anyone building in big tech is taking on some sort of massive opportunity, and whether it's humanoid robots, world models, materials, these are all huge categories, and it can be tempting to try and boil the ocean. But
you already have a huge ambition.
Huge ambition. So the real challenge is then how do you define a set of milestones that make sense, that can align to funding goals you have? How do you really, focus constrained resources towards a problem that is going to differentiate you from what are very competitive spaces in the early days? And so that, for us, that was building a safe robot to be around, and that was true mechanically speaking. But then we invested a lot from an AI perspective in training robot behaviors that were capable but compliant. And so, creating a clear through line, a set of milestones, and just being very deliberate on how you spread your investments when
are the fundraising milestones and the acquire milestones like the same? Because for the acquirer, it's like it needs to be something they want. Whereas like I guess the funder, especially if you have investors who are willing to come back around, you can sort of pre-negotiate if we do this. You're still on the
I
journey?
think they're similar, but you always got to kind of play it a couple rounds ahead. And I think both spaces we're talking about, but in robotics specifically, it is one of the most capital intensive endeavors that one could undertake. And so thinking very hard about if you take this next round, what does that mean for the subsequent round and the round after that? Like what is the trajectory that gets you to either an independent, sustained self-sustaining company, or are there partners that are important to develop along the way, such that you have a clear path to building the business that you set out to build?
You could become unacquirable if you get to a certain scale. All right, questions from the audience? Great. Here, I'll bring it to you.
So I have a question for Rob. So I've been learning about Sprout in my courses, and I find it really interesting that it's a smaller robot. I just wanted to ask, compared to like the average humanoid, where do you see Sprout in like a person's everyday life?
So for those, Sprout is our first robot. It's 3.5 feet tall, 50 pounds. It has 2 arms, 2 legs, articulated eyebrows, and LEDs around the face. So it's cute and engaging, but it's also capable of interacting with doors, refrigerators, elevators, navigating autonomously. And so I think there's a lot a robot like that could do in the home. And our starting premise was, it has to be safe so that people trust it in their home to start with. And that same robot could learn to climb a ladder, right? And that might actually be the first thing that people want and are excited about, and is capable of doing many of the household chores that we one day care about. And so that was our approach to the problem of how do you build a general purpose machine that then can be useful near term.
Pim, I did want, what is your agent stack, or how do you supercharge yourself as the CEO? Clearly very technical. What is to you the cutting edge of having the models today assist you in your job?
You can't give that away, dude.
No, yeah, and I do want to make it very, very clear. We are on an incredible curve, right? The system, the capabilities are incredible. I'm a big Cloud Code power user. One of the things that we're rolling out internally are systems that connect more pieces of the whole organization so that anybody can hook into Cloud Code. We also have so one of the things that's interesting that we did, we have a data analyst, so we were always understaffed on data analysts. And then there was a QA person from the team. So one thing that we did is we did a hackathon where we told everybody to go build things around Cloud Code and also the different models that we did at the beginning of the year. And one of our QA team members built this thing called ML Data Buddy, where basically it's just a Slack account, like a bot object, and then you can just talk to it, and it just is your data analyst, right? It's SQL queries, you get it back, it's Slack message, you can just talk to it, and then now he has made it so that it scales alongside the number of questions it's getting, and it feels like you're just talking to a coworker. And this has just felt very natural and very good. And we all started using it like crazy, to the point where database was getting overloaded because so many employees at the same time were asking highly concurrent select queries. So that worked really, really well.
Is that you like things that are at the company level rather than thinking of yourself?
I do it in my personal life too. So I have some automated workflows that go and download my personal files from a lot of the services that I use, and then I can ask finances. I can ask Cloud Code put together a report of this or this or this, and then I just give it data sources, and it just goes and does it. It's quite helpful. I have it connect to my calendar. I use it as an interface to all the complexity of clicking around, and that's very, very helpful.
Another audience question?
Hey, I'm Anjeet. I'm CEO of Pillar Space Systems. We're building some space hardware. I had a question for Joe. How did you approach the Raytheon angle? I guess it's really cool that they're investing in you. How did that come about?
Yeah, so I think as all good relationships do, it came from a business need and the customer side. So we met with their research teams around what problems are you trying to solve, and how do you do materials today, which morphed to you should meet the ventures arm. And I think we're in a very unique time, which I might get in trouble for saying, but who cares? That defense is having a huge push on innovation. And for Raytheon, it's not actually just defense, but the RTX umbrella, they also have United. Actually, their biggest business line is Pratt & Whitney, making turbines. And so they're having an even bigger push because they're feeling all of this innovation push from defense and aero on we need better planes, we need longer time, we need better jet fuel, just this constant push on innovation. And so they, I think, had a different lens to looking at a company like us, where I don't know for sure, but 5 years ago it might have been harder to understand this early. I think later on, most likely, like when we have a product and they know what we're doing. But I think their team was deeply convinced on, okay, we know AI is going to change materials. We know self-driving labs are going to make a big impact. We don't want to have the expertise to do that. We build jet turbines, so we should work with someone who does. And I think that was where there was a very congruent relationship. Hey, dude, we're never building the jet turbine. Like, we don't want to compete with you there. We want to build materials, and yeah, great, we're not a materials company. We don't want to compete with you there. There's a really kind of good synergy that we formed together, and I think the rest is history from there. So,
Super interesting. Yeah. Right here, started in the front.
Hi, thanks for coming today. I think we all acknowledge how constrained the supply chain layer is foundationally. Given how fragmented the hardware supply chain is, how are you deciding what parts of the stack you need to control versus rely on externally?
For us, it's you actually find the common denominators. We found that common denominator to be like the game controller interface, for example. But you got to find like you find the interfaces that actually have a simple way of deploying into them. And I think a lot of things are sort of downstream from there. And sometimes you have to create the interface, like the robots, and that's really, really like, hard. And then,
it's cliche, but true, like first principle analysis. If there are tools that we buy that have 36-month lead times. So the first question we ask is like, what is the benefit of acquiring the tool? Why are we acquiring the tool? Like, what is the use case of the tool in the future? If it makes sense to custom build that, or make some type of alteration to use it quickly because we see it has X, Y, and Z use case in our business moving forward, then that makes sense. If it's like a one-off, or like we don't have any other people that want that tool, we just have to do that for this contract, you're like less inclined to want to go take on all of that. That's so much technical risk, capital expenditure, and even focus. And I think one of you mentioned focus earlier. Like, you can boil the ocean very quickly. Like, you start talking to customers in deep tech, and next thing you know, you have 17 different problems to try to solve. You need to be very good at, that's a cool problem, like, we don't work on that. That's a cool problem, we don't work on that. And I think you are constantly doing that as a founder. Like, if you are not doing that as a founder, I think you're actually failing the organization, particularly early on, because the best skill is saying no, right, as the saying goes. And I think you have to be really just laser focused on, we are solving this because of this. If a hardware requirement meets solving that, I will build it. If it doesn't, I'm going to find another way to get it. That's the way we think about it.
All good, succinct audience questions. I love this crowd so far. Who's next? All right.
Yeah, I was wondering how you think about, with like materials, for example, the kind of just like throughput constraints that exist on building stuff out. And so, like, for example, I think Google DeepMind had like 2.2 million materials they discovered. They think 40,000 are stable. It's like, okay, how do I make all of these? And then how do I convince people that they work, right? And to your point around, like, we're using 100-year-old alloys, I think part of it is that people know the stress-strain curve and they've used it for 100 years. And it's like, even now that we have like 40 different concrete alternatives, like, you can't build a house with them because like you can't get that in building code. And it's like, how do you think about that when you're talking about critical industries like defense? Like, oh, you should use this new alloy I've invented that, like, trust me, it works. And like, we should put, pilots and stuff in there.
Yeah, really good question. I'll touch both parts. So on the latter part, it's called qualification in the aerospace industry. And for those in the audience, qualification is essentially the process of confirming what this gentleman said, which is, hey, we feel safe to fly that. Like, that's going to fly in a fighter jet, that's going to fly in a manned aircraft, or it's going to fly on something else. And ironically, I think in some of those industries, you're actually seeing the companies who make the end products vertically integrate. And we were surprised by this when we went to market. We thought we would have to vertically integrate immediately to like get material to production. And instead, they're actually vertically integrating from the top down. So these aerospace companies are saying, we are tired of dealing with the qualification requirements of the US Gov or any other administration or kind of organization. We're just gonna do it ourselves. And I can list off the top of my head multiple companies who you are all aware of that have material teams in-house bypassing qualification for their own systems. Now, In aerospace,
Which means the government then certifies the whole.
yeah,
rather
so
than
there's like
pieces.
these like lists that the government has. I think FAA runs one. There's a military spec list as well for manned aircraft as well as like missiles that control like if something is qualified to be used in those systems. And so obviously like for commercial aircraft, like they're going to follow that requirement. They're the slowest, least innovative people in the world. But like for aerospace, space, they do not, in some of their systems, need to follow those. They're launching their own rocket on their own dime. And as long as they're doing that in a way that they can prove is safe, they have already done own custom alloy development. I've seen it before. So the qualification piece, I think, is you're seeing this, again, the stack come the other way, and the throughput will be the bottleneck there and how much they can actually make because they're not material companies, they're aerospace companies. So that's kind of the second one. On the first one, the throughput side is the hardest part in science. And so one of the reasons that Genome or MatterGen or any of these papers that have come out have been poor is they're trained on computational data only. And computational data is cool, like it's fun to simulate electrons, but it's not the real world. And if you call any customer in the world and say, look at this amazing material I made you on my computer screen, they'll say, yeah, cool. Can you send it to me in the mail? Like, can I use it? Can I actually put it in my product? And if the answer is no to that, then I don't think you've actually discovered a new material. And so when you see these models kind of coming out with new materials, they're not new materials, they're new ideas of materials. And until you can make them, you don't have new ones. That's why self-driving labs are super important. That's how you solve the throughput problem.
Sure. Can you?
Hey, thanks. Thanks for the thoughts here. LLM revolution was powered primarily by publicly available data sets that were mostly accessible to a lot of the labs and a lot of the people. When we switch to physical intelligence, robots, world models, how do you see the data bottleneck? How do you overcome it? How do the use cases map to data? So we hear about game data and so on, but in games primarily it is first-person shooter and so on. And if I want to teach my robots how to lift boxes in a warehouse, how do you actually map that use case to what data you need, and how do you get that?
Yeah, so that's why world models are so important, because you don't want to train a model to predict violent actions, but you also want the model to be able to simulate environments that can do that so that you can evaluate your agent against it. And you want to train on the positive actions and evaluate on the negative ones, right? So that's why you don't just run like large-scale imitation learning and then shoot that agent into the real world. You use world models such that you have an environment that understands all the possible unfolding dynamics, and then you use an agent and reward them specifically for the behaviors that you actually want to see. So it's actually the counterpoint to that argument is actually that you need games to simulate the scenarios that you want to avoid against. Now, I would argue that the entire field is still in the research phase. There are no like, and again, I'm kind of somewhat artistic, like no known scaling laws that are like, there's some, but not like in text world where you just can predict like what type of data you need for what type of thing. So that's the difference. I think everyone's still figuring it out.
It's not like Tesla inhales all this data and the huge advantage. You don't think there's?
They do, and it's for sure useful. But I think the general solve, which is what I think you're asking, the general solve like LLMs, those scaling like there are scaling laws for specific embodiments for specific situations. Like driving is better than others, but the general solve is not as clear as LLMs. I think there's ideas.
Yeah, I mean, I think what is working today is in places like self-driving cars, where it's a fairly straightforward controls problem and a more complicated environmental, spatial understanding problem and model you can build around that. But the same is true in robotics. Like the things that people get working are actually quite narrow. Stair climbing, door opening, packing a box. Like these aren't one models that solve all of these problems. And that can either be with real-world data. We rely a lot on simulation.
Is that true with like physical intelligence? I mean, they present it as very broad. You don't think the folding laundry is like generally applicable?
I mean, I don't think it's solved, and I don't think we yet understand the scaling laws associated with current approaches to say that with just a bit more data, laundry is solved.
I agree, fully agree. I can, if we have some time, I can try to go into how to think about the scaling laws, but it might take me like a few minutes. So you tell me.
It's hard to preview if this is where, I don't know. Give us just like a couple bullets and people
I'll
can
try
follow
to.
up with you.
So there's complexities related to the degrees of freedom of the robot, right? And then, so a humanoid is like large degrees of freedom. A self-driving system is like very low degrees of freedom. And so your scaling laws are different depending on the degree of freedom. Then within the degree of freedom, you can have different types of predictions, right? So if you're predicting at the level of a game controller, you can just predict like a bit or like a digital value. But if you go for a robotic arm, you might need to predict like motor torque or something. And so every degree of freedom has like different values so there's complexity there. Then, so there's scaling laws on the degrees of freedom on the input space. Then there's scaling laws on the environment, right? So where the robot operates. And then there's scaling laws on the sensors themselves. And so like anybody kind of claiming that they have a very general solve is like full of shit. Yeah.
I love this
Yeah.
crowd. New York is doing it. Oh, yeah, I should. Okay, great. Enthusiastic. Go for it.
All right, thanks. So you have a material science company, and one thing that you said about like cars 100 years ago, they use all these old alloys, but they also only needed like 5 or 6 elements, and then a car today needs like 150. And so can you talk about where the raw materials are coming from and how those raw materials get into the pipeline of what you're doing in your company?
Really good question. Probably the question I get the most when I go to Washington, D.C., and I'm on the Hill or at the Pentagon or at the Department of Energy. Like, where the heck do you source those things? And I think you're seeing a big, critical minerals has been a talked about area a lot. It's the derived products category of critical minerals that is super interesting. And there has been a focus from D.C. on, like, what are these things actually going into? And so I'll give you a perfect example. C103, super common alloy in aerospace and defense. It's got cool properties. You can read about it. It's made with hafnium, and it has a high weight percentage of hafnium. Hafnium is almost entirely, I think it's like 90-something% owned by China. So now DOE and DOW are very worried about hafnium content in their materials. So not only is there a question of, can you make a new alloy that's got way better performance? We actually get questions like, can you make the same alloy, but with no hafnium at all? And we've been able to do that, like we've done that successfully, but that is almost a different materials problem because now you're trying to hit on the same property constraints, but just remove the inputs. And that's a different problem than different inputs with maybe different property constraints that allow you to kind of extrapolate the periodic table more. We can go use a refractory metal to drive strength. We can't use a refractory metal in C103, or like a new refractory metal in C103. So critical minerals are continuing to be really important.
But you're saying your philosophy is mostly to try and like cut out minerals you don't want rather than find
So
creative new minerals?
You can. There are places where it's really hard to. Like nickel-based superalloys, they just have elements that we don't control. And I think that's why you see like an effort in dollars in onshoring. Because there has been an acknowledgement, no, we probably cannot get rid of them. We better onshore or nearshore that technology rapidly. There are some elements where I think there is a push to get rid of. I think people had shown that niobium-based alloys, the high entropy field, had really cool properties, and there might be materials in there, I can guarantee there are, I know what some of them are, that don't have hafnium. And I think the field was convinced on that, and it's kind of where it's pushing today. So it depends is the like unfortunate real answer.
One last question. I think I've been avoiding you, so.
Sure. In each of your sectors, how much do you worry or used to worry about competition from mega capitalized labs and corporations?
0. I have a very unique view on competition. I rarely think about competition. I just think it is such a waste of mental brain space in that you have one job as a team to execute on what your mission is and be the best in the world at that. I pay attention to what our competitors do. I'm not naive to what the market's doing. I'm just not like drooling over the fact that they've come out with a new release. Like, I hope you did. I mean, otherwise, like, what the hell are you doing all day long? I mean, we're doing the same thing. And so You have near competitors and startups. I think you should be aware, like big tech or like big labs in very unique spaces. I just think they just have no chance of competing. In more generalized spaces where they have raw compute or raw data, like ads. Ads is probably a tough space to compete with Meta and YouTube. I don't know. Like, I don't work in ads. But in materials, I don't think Meta is going to compete with us in materials, or Microsoft, or Google, or really any of them. Personally, that's just a personal.
How much do you think about the competition?
I think so. Why is Anthropic winning? It's because they are close to their customers and they like put their evals and like model training runs, and they like how much do you really care about like the 1% benchmark versus what your customers are actually using? They just move fast with their customers in a way that OpenAI and Google can't, because they are larger, more bloated organizations that are more distracted.
Your answer is I specifically worry about Anthropic.
No.
Read between the lines?
No, I'm giving you it as an example of like Anthropic was not the incumbent in the space that is now looking like they're actually winning, right? They were in that position and they won by focusing on their customers and ignoring everything else, and by focusing on code.
And I would argue, and I don't know them, I didn't work on Anthropic, that they did that by like not worrying about what OpenAI was doing and like
Customers.
what customers.
Yeah.
Customers. Like,
Listen to your
what do
customers.
people like? What do people like?
Rob, I mean, you're sort of the flip side. Big companies can be good. Or
Damn, you gotta be super careful with this answer.
I think there are things that small companies can do that big companies really struggle to do. I said it before, but focus and attention and like a very opinionated product is very hard to come by in the earliest stages at big companies. And so I think you can build up momentum on a trajectory, and you got to be right about where you're choosing to focus, that is a problem that matters and it'll be differentiated. But pushing hard on that thing is something that only startups, I think, can do very effectively. And so we got to a point where I think we had enough of kind of a kindling fire that it made sense to have a big partner and to help that grow. But in the earliest days, it's about how do you get that spark into something meaningful, and that's harder for big companies to do.
Couldn't imagine a better last word than that. Ode to startups. All right, this was awesome. Great crowd. Thank you.